Hello everyone. I would like to continue with the previous video. I kind of stopped right here when we have to convert 68 times 10 to the exponent negative 7 gram to milligrams and then to microgram. Okay, so what I have done is I asked everyone to use the method of converting the exponent, so which is method number 2. So I'm going to write it here. So our method number 2 is involving the exponent, and it's up to you to use whatever method that you are comfortable with. Using this method number 2, what you need to do is you need to uh, know how to work with the exponent and know how to break this exponent into different powers of tens. Okay, so right here I have milli. Okay, so milli is a prefix that representing 10 to the exponent negative 3. So what I have done is write down 10 to the negative 3, but I originally have 10 to the negative 7. So from 10 to the negative 7, I write it as 10 to the negative 4 times 10 to the negative 3, because negative 4 plus negative 3 could give me negative 7. Okay, so you base on this in order to pull out the correct power of tens to work with. So I pick 10 to the negative 3 because I work with milli, and the remaining power of 10 to give me 10 to the negative 7 is the 10 to the negative 4, because I am using these formulas. I am using am times an equal to am plus n, okay, and vice versa. So I kind of practice the this side of the equation equal to this side of the equation. Okay, so from negative 7, I want to have a negative 3 in it, right? It's because I work with a milli, so I pull out the negative 3, but I know that I have to write the negative 4 because I need to get back to my original values. And now with 10 to the negative 3, I convert that to a milli, which I already have here. So that's what I replace it by. Then now what you have to do next is you need to convert this number here from this notation to a decimal notation or a standard form. So for me to do this, you can see that in order for you to convert it back to the decimal notation, you have to locate the decimal point. So right here is the decimal point, right? And I am going to move the decimal point 4 places to my left because I want to make this number smaller. So the exponent 4 will tell me that 4 spaces that I have to move the decimal point, and the negative telling me that I have to move to the left. But if you don't remember left or right, just remember that it's a negative, so you need to make this number smaller. So by moving this 4 spaces, I ended up with 0.0068. Okay, and for this number, okay, 6.8, where do I get it from? And it's a microgram. Okay, so if I still base on this number 68 times 10 to the negative 7, so what you see right here is because of the micro, I know that micro equal to 10 to the exponent negative 6. So I am going to write this as 10 to the exponent negative 6. And then because I work with negative 7, so I know that I already have negative 6 here. To make it back into negative 7, I have to have 10 to the negative 1. After I have this, it's already replaced by my micro. What I have left in this number is actually 10 to the negative 1. So 10 to the negative telling me that here's my decimal point, right? So I need to move it here. Right? Okay, see that? I have to move it there. So now that's why I have 6.8. Okay. All right. All right. Okay. So that's why I have 6.8 microgram. So again, if you still prefer the method 1, I can do method 1 for everyone. That means I can just convert this 68 to 68 times 10 to the exponent negative 7 to a decimal notation. Excuse me. I'm sorry, I just get a bit distracted. That's how we work from home. Okay, so teaching remotely, work from home. Um, okay, so I will write this as, I just want to pick the color, that's all. Because using the software, I can pick the color. So I'm going to choose a different color here. And then I will put 68. I choose purple now. Okay, so 10 to the negative 7. All right, so let me try to rewrite this. Okay, so one thing about doing mathematics is don't rush. So if you rush, I did rush earlier, and I think I am okay there. So now, all right, so first of all, I am going to convert this into a decimal notation. And honestly, I I really don't want to work with this method one because sometimes it's just too many zero and we often miscount the spaces. So, however, here is my decimal point. All right, so there. And I'm going to move the decimal point 7 spaces to my left because I need to make this number smaller. Okay, so here I will decimal point go 1, 2, 3, 4, 5, 6, 7. So the decimal point now will be right there. And therefore I will have to put in 1, 2, 3, 4, 5, 0. Okay, so the number now will be 0.2345 and then 68. Okay, so this is the decimal notation for this number 68 times 10 to the negative 7. And now, having the decimal point, you can go ahead and move this decimal point to where you want to move. Okay, so if you don't want to work the exponent, you can just go ahead and use this method. And now, this is, don't forget this is gram, so I better write it down, gram. So that means, according to our chart, the grams is right here because it's the unit. So right here is just the unit. Okay, and no prefix. So that means you start at 10 to the 0. And don't forget 10 to the 0 is 1. Anything raised to the exponent 0 is 1. Okay, anything raised to the exponent 0 is 1 except for 0. Okay, so right here I just want to keep everyone informed of the another formulas that we should know. So this is the unit. So if I move to my milli, that means I have to move to the right 3 spaces. Okay, so in working with this method, you will have to go to this line. Okay, and go to micro, I will have to move 6 spaces to the right. Okay, so now go back to that question. Back to that question. Excuse me. Then you will see that I'm going 1, 2, 3. So that's why I am with this number, you see. Then it's 0.0068. And then you continue moving until you meet the micro. So that means you continue moving this 3 more. 1, 2, 3. So that's why I will have the 6.8. Okay, so if you found method 1 is a lot easier than this exponent method, then you can go ahead and use it. It doesn't matter. Okay, so let me show you the exercise that I asked you to do. So here's the exercise. It's quite a bit. Okay, it's a very good practice. All right, you need it in physics and you need it in any technology program that you go into. So engineering notation is very important. It's way more important than the scientific notation. Okay, so scientific notation is more like introduce you to the power of 10, but what you always have to remember is um, hold on a second, I'm sorry. All right. So what I have here is a lot of questions that I would like you to work on. All right, a lot of questions for you to work on. And I was saying that engineering notation is very important in terms of any program that you will enter in. Is more important than the scientific notation, because scientific notation is talking about the power of 10. So scientific notation talking a power of 10, so you are familiar yourself with the exponent part of it. But engineering notation applies to every single problem that you are working with in engineering. Okay, so that's why I assign quite a lot of homework here for everyone to work on. Okay, and what I will do is I will work with number 12. Okay, number 12, and we very much similar to this, and I will work with two methods as well. Okay, and again, I do apologize for earlier. You probably hear that I have a full call coming in. Okay, so I actually just turn it. I did turn it off, but for some reason I have an old phone. Um, anyway, all right. I always want, like, it's better to be in the classroom, right? So, but here's face to face, and you can only hear. It's not face to face. Here is, we have to be online. I'm sorry, I apologize again. We have to be online, and then you know how it is working from remotely from home, and uh, and you know that when you study at home, uh, it's also you have distraction as well. Okay, so now what we are going to do is for this question, I am going to work with two methods also. All right, because I really want everyone to master the concept of the exponent. Okay, so number 12 looks like this for the exercise that I assign for everyone. So for number 12, I am working with uh, 16 times 10 to the exponent negative 7 ohms. So this is ohm. And I need to convert into micro ohms. And I need to convert this one into nano ohms. And you know that now I'm not going to like try to go to my number line, start moving stuff. Because if I work with method number 2, I know that micro is 10 to the negative 6 and nano is 10 to the negative 9. Okay? Okay, so let me confirm that with everyone. Okay, so you may have to try to memorize this. Okay, I know that some of you in the pre-technology program, you probably learned this already. You need to know this already in your physics class. Okay, so here is my micro, which is 10 to the negative 6, and nano is 10 to the negative 9. Okay, so you don't need to memorize this. Every time you forget, you can go ahead and refer to that table or that chart or that number lines. Okay, so we are talking about number 12, right? Okay, number 12, and ohms is a unit for resistance. Okay, ohm is a unit for resistance. So first of all, this is what I ask you to do. I'm going to ask you to identify this is the 10 to the negative 6, and this one is a 10 to the negative 9. Okay, so this method is actually quite good. I prefer the exponential method, okay, because it's trained us to work with exponent, and we don't have to count our zero all the time, okay. So now what we do is I am going to rewrite this number as 16, okay, times 10 to the negative 7, right? Okay, so first of all, you need 10 to the negative 6, right? So you are going to write 10 to the negative 6. And then here's your 16, okay, time. You know that in here, in this space, you need to time it by something. You need to time it by 10 to the something, so that something adding to this will give you negative 7. So you need to get back to your original power of 10. So why do I break into 10 negative 6? Because I know that 10 to the negative 6 representing the micro. So 10 to the negative 6 here, in order for me to get from 10 to the negative 6 back to the 10 negative 7, I need to multiply this by 10 to the negative 1. So why I'm talking of this, you probably figure it out that you need to get 10 to the negative 1, right? So now you are going to replace this by the micro. So what you have left is just this, 16 times 10 to the negative 1. So 16 times 10 to the negative 1, this number 1 here will tell you that you have to move the decimal point one, one place to the left. If you don't want to remember the left, you know that, okay, it's negative. I need to make this number smaller. So I'm 16. The decimal 1.6 will make this one smaller. So now in this case, the answer is in fact just 1.6. Okay, so very good. So this is 1.6. Okay, simple. I do feel that it's simple. Okay, you can do this in a split second. Okay, the reason that because I explained to you, so we go over this length, but you probably figured this out already, right? You have figured this out already. So now we are going to work with 16, 10 to the negative 7, right? And then what you need to do is you need the negative 9. So you rewrite negative 9, and then 16, and in here is you have to figure out the 10 to the exponent something that you add that with negative 9 will give you negative 7. You can quickly do a math here. Okay, what number adding negative 9 will give you negative 7? Okay, I pause a minute for you to tell me what it is. Of course, you cannot tell me what it is. What am I talking about? You probably write it down already. Okay, you probably write it down already. So that means you need 10 to the exponent positive 2. Agree with me? Okay, I think you do. Okay, 10 to the 2. Okay, because if you take 2 plus negative 9 will give you negative 7. Isn't that neat? So I think this method is so I make a note here. Note 2 subtract 9 or adding negative 9 will give me negative 7. Okay, adding negative 9 will give me negative 7. So that's why I am writing it as 10 square. Okay, so am times an equal to am plus n. Okay, so this formula that we've learned in previous lesson is actually quite useful now. So you are going to replace this by your nano. So this one become your nano, which is the small letter n. So what you have left is this number. You see? So 16 times 10 square. So you have to insert 2 more 0 after the 16. So now the answer will be 600. All right. Okay. So I hope uh, I convince you to practice this method so that you will master the concept of a prefix. So, and then it's power of 10. Okay. However, again, if you still don't like this method, you still don't get it, method 1, I can try that. Okay, I can try that, but I can tell you that I don't think I do a good job with the zeros here. All right, so the 7 0 that we are talking about. So here is the 16. So we have 16 times 10 to the negative 7. So what I will do is I write 16 And then I start moving my decimal point, right? So the decimal point is here. I go 1, 2, 3, 4, 5, 6, 7. So that will be there. So now I will have 1, 2, 3, 4, 5, and there it is. So the number is 0.00000016. Okay, so 1, 2, 3, 4, 5, 6, 7. Okay, so I have 7 numbers after the decimal point. Now you can go ahead and move your number to where you want it to go. Okay, so in this case ohm, you go to micro. Okay, so that means you have to go how many spaces to from the non-unit to the micro? 6. Okay, so I need to go 6 space. So I go 1, 2, 3, 4, 5, 6. So that's why I have 1.6 micro ohms, right? So this is ohm. And then what you do is you can go from micro ohms to nano. So that means you have to insert, so from this number here, so 1.6, you are going 1, 2, 3, right? So that means you are adding 2 more 0, so will be 1600 nano ohm. Okay, so if you don't like the exponential method, you still can just apply uh, the zeros here. Okay, but sometimes this number can be very big or very small, like let's say you have 18, you have like negative 19, and then you have so many zero to write, instead of just apply the simple method of adding the exponent, or play around with the exponent in this case, in terms of the power of 10. All right, so that recap the lesson. Okay, so like I said, engineering notation is very important. It's applied to all technology program that you may go into, and in other program as well. And we need to know our unit of measure and the standard unit here in order to work with the engineering notation. So because all of this unit will be part of our engineering notation. Okay, engineering notation is you have a prefix attached to a unit, and each of these prefix will have its own symbol and its own power of 10. And it goes from the top to the very least here, so it's a very big number to the very small measurement, and it's all representing by the decimal of the the 0, and presented by 10 to the exponent. Okay, from the 18 to the negative 18. And the difference between all of this increment, the increment is actually 3. Okay, so therefore, if you put it on a number line like this and you move the decimal point, even though I just put like 1 space here, you need that to know that in between here are 3. Okay, 3. So more than like here you have negative 1, negative 2, negative 3. But this is not applicable to the integer line that we were talking about. Is that right? Okay, because the integer, sometimes they presented the negative on this side and the positive on this side. Okay, so this line representing from the biggest to the smallest. Okay, so this the biggest is 10 to the 18 to the smallest of the negative 18. So you have to memorize this line. Okay, put it on this chart and memorize this line. Or you don't have to if you apply the exponential method. Okay, so in this case you see, so I can tell you that I can apply the exponential method here too. Okay, so I can quickly try that. Okay, so I can quickly do this for you. So 0.00864. Okay, so I want a milli. You see that? I want a milli. So that means that is has to be 10 to the exponent of minus 3. Okay, so what you can do first is you are going to convert this one into the 8.64 times 10 to the negative 3. Is that right? You convert this into a scientific notation number, and then your 10 to the negative 3 is in fact equivalent to your millis. I don't have to move my decimal on that line. So I know that this part here, 8.64 times 10 to the negative 3, representing this number, and then 10 to the negative 2 replaced by that. But sometimes it's just simple just to move the decimal point. All right. Okay. So it's entirely up to you. You move the decimal point, or you usually we start using this method if we have an exponent or the power of 10 to work with. And in this case, sometimes because of this exponent is small, so you can easily convert this into this decimal notation, and then you move your decimal point. Okay, so let me double check everything that we have done for this particular lesson. Okay, so I hope everyone is working along with this as well, and kind of knowing what to expect when we convert from one unit to the other. Okay, 1, 2, 3, 4, 5. So 4 to 6, so this one is also good. Okay, and then we are going to move on to this number, and then we should have 4 zeros. 1, 2, 3, 4, 0. Okay, and then and here we should have the 2400, which is again whatever method that you prefer, it's up to you. And this one again, method 1 and method 2, and the first one should be 5600, and I just want to circle this and this together just to show everyone why we have that. Alright, okay, and this one and this together here. Okay, maybe I should use another color. Okay, and this and that should be this. Okay, very good. Alright, and you can use the other method if you want to, and at the end the answer should be the same, right? So 0.0068 or just 6.8. So this is also we double check this, and then I went over number 12 for everyone, and there's a lot of exercise here for everyone to work with. So number 12, the answer for that should be 1.6 and 1600. Okay, and both methods we checked them both, so they should be fine. Okay, so I really want everyone to try the exercise. All right, and then I have the solution posted online. Okay, what else do I need to say? I don't think I need to. I probably said a lot already. So okay, so this is our scientific notation. It has something to do with our engineering notation, because engineering notation will have the unit attached to a prefix, but scientific notation has a lot to do with the power of 10. All right, okay, so I would like you to distinguish the difference between the two. And remember that engineering notation is very important. Familiarize yourself with the unit and also with the prefix. All right. Thank you, everyone.